Hello.
Hey.
Hey.
Oh,
Levi.
Hey.
You gotta watch out there.
Brendan.
Whoa,
Brady. I'm doing vocab and context. You're doing...
Oh, data interpretation.
actually
I thought you were
know.
going to say
Yeah,
it.
but I don't know.
I'm doing data interpretation.
And I'm gonna be answering your questions on the little chat room.
You can actually take Vinroy's question if you want, because
Yeah.
Vinroy asked on the
You
Discord.
know what? I think I will.
There you
He
go.
actually didn't ask a specific question. He wants
He just wants
systems.
in general systems of equations.
Oh, okay, I can
Inequalities.
take that.
Systems of inequalities.
Did he say inequalities?
Yeah, I think so.
Yeah.
Okay, just checking on the
I
Discord.
can take that.
This code.
Today, for those of you who are used to this, you would expect me to be going first and doing some math. Levi's a little anxious.
You can do it.
No, I just don't want to do it first.
Are you
I was
anxious?
going to try to give it a reason to why.
No.
No, Levi's going to start
No.
with vocab and context. For data interpretation, we covered that a bit last week. So if you have any questions about specific data interpretation questions, let us know. Otherwise, we're going to kind of go through it as if it were a quick review. And then we're going to open the floor to
Debate.
a lot of questions. Just kind of open-ended questions from any of you. And we'll
I
go
guess
from there.
we could always, it is always a debate. If you think you have a better approach to a question or a topic or whatever, tell us, and then we
Yeah.
will
Tell you why
talk
you're
about
wrong.
it.
Exactly.
Oh, yeah, what he said.
We'll talk about it like
Yeah.
adults.
Yes.
They're not adults.
You are not an adult.
You're not an adult.
I get to act like one
Off,
sometimes.
off,
decided
off,
about
off,
All right, hey, I think he wants us out of here.
off. Can you turn on the overlay for me?
Maybe a real
Please.
adult
Oh.
could. Oh, got him there.
He's got.
ACT?
Yes. Where's
It's charging. You want me to get it for you?
Yeah. History double passage strategy? The Kush G. Kush G. 1, 2, 3. Okay. Wait, thank you. Yeah, we could go over history double passage strategy. Let me just do this. I think if you're the person who asked on Reddit for that, we did that on Monday. If you want to go back to see that, otherwise you can hang around and we'll get to it eventually. This we're doing vocab and context. So if we go to this passage, sorry, this is the ACT down below, ACT FPRE 74 FPRE. This looks like passage 2. What is the question I wanted to do? Here we go. Okay, this is the second passage here. As it is used in lines 82 to 83, the phrase whatever, or in this case, named and nurtured most nearly means what? Okay, this question, the question tells you what you're being tested on. This is a vocab in context. So that means what it says, vocab in context. That means it's not asking you to define this word because all of these are valid synonyms of, named and nurtured. We don't care about what we can interpret as a valid synonym. We want what the passage wants to say. That means we go back. That's all. 82 to 83. So let's just read it from the beginning of the paragraph. And whittle away we have done. Here in North America, according to apple historian Dan Busey, some 16,000 apple varieties have been named and nurtured over the last 4 centuries. Okay, so 16,000. So this is an apple historian, and 16,000 apple varieties have been named and nurtured over the last 4 centuries. Let's see what we have here. Nominated and encouraged. I don't like the word nominated because nominated has to do with elections, and we're not electing apples, so that doesn't make sense. That's too human of a trait, I think. So, nominated. Oh my gosh. Didn't even bring one of those today. I don't like nominated in A. Let's look at, F. Let's look at G. Identified and cultivated. Identified and cultivated. That's not bad. We're identifying these apples and then you cultivate apples. That's a very farming term, so I like B, or darn it, G. H. Pointed to and groomed. Salutations, Vinroy. Welcome. I don't know if you heard right at the beginning of the stream, we said we will answer your question once I'm done, and then Brady could do it right after that, or we could we'll just do it right after I'm done. And this will be quick. It's just vocab and context. Identified and cultivated is fine. That seems to work. Pointed to. I don't like pointed to because it's not we don't care about pointing to apples. That doesn't really make any sense. So let's get rid of pointed to. That's out. Then we have cited and fed. Okay, Cited seems a little bit odd because you normally cite sources, and we're not citing apples as sources. I don't love that, but maybe it's okay. But fed, you don't feed apples. You feed apples to people, but as a direct object, you don't feed the apples themselves. I would say that definitely fed is wrong, which leaves us with G. Woo! That's F, so I circled F, but do as I say, not as I do. All right, so this is vocab and context. It's very straightforward, but it's also very easy to make a mistake. So this is just like basically every other question type. They can be very easy and they can be very challenging, but they're all possible to make mistakes on, and especially for those of you that are, actually, it's for everybody. For those of you that are, pushing those last couple of points, and for those of you that are trying to get those middle to upper points, if you make a simple mistake, that's your problem. It doesn't matter if you don't understand that last math problem if you get the first one wrong because you make a simple mistake there. So it's the same issue in this case. 16 is that. If you have any questions about this, let me know. I think it's pretty straightforward. Let's just do one more to solidify the this approach, because we want to do it the same way every single time. That way we can be good at the approach itself. I don't want to do that. I don't think that works super well. Do we have any? Ooh, you know what? This might be the section that doesn't have a lot of vocab and context. I did see one here. Let's see if there's one in the beginning, though, because I like the beginning more. No. Yeah, this is a terrible test for this. Actually, Brendan, can you hop over to the SAT?
Yep.
Yeah, I don't want to do the ACT for this one. There just aren't enough questions, and there's one, but I don't like the way it demonstrates what I'm doing.
You're good.
Lovely. Now we're on the SAT. It's also down below, reading section, so first section this time. Same issue. Okay, line 2. There we go. In line 2, turn most nearly means what? Okay, if you look at the answers, all of these could mean a turn. So that's not where we're looking. We're looking at line 2. Let's go back there and we'll see how they're using the word turn. Oh, that's not what I want. Let's move it up a bit. Okay, starting from the beginning, of course. Lady Carlotta stepped out onto the platform of the small wayside station and took a turn or two up and down its uninteresting length, to kill time till the train should be pleased to proceed on its way. Okay, so this is one of those old Englishy passages, but she took a turn or two up and down its uninteresting length, and then it defines what she was doing. So that's literally what she was doing. And then the context is telling us, or describing for us, her actions. And her actions are to kill time till the train should be pleased to proceed on its way. So she's killing time. She's hanging out. She's probably bored. Let's keep that in mind when we are trying to define this in context, because that's what these questions are about. Number 2. Slight movement. Okay, I don't really think that makes too much sense. You don't make slight movements up and down a train station when you're trying to kill time. That doesn't really work for me. So let's get that one out of there. Change in rotation. Okay, rotation is odd. We're not talking about this woman on a train platform rotating. That seems out of place. Short walk. Yeah, not great. It's not that interesting, but sure. And then course correction. No, that's much too scientific, much too aggressive. I don't like course correction. And so we're left with short walk. Now this answer choice, this can happen. This is why we need to prove 3 wrong. This answer choice is not the most sexy of answer choices. It's just short walk. But that's what it means in this context. We're talking about her being bored, so we're going to use a bored, very normal definition of of turn. And this is an older definition of turn, and this is why it doesn't matter what that word is so much. Use the context, not the word itself. Okay, I'm going to stop there. This is a very simple example, unless somebody wants to take a photo of a really hard vocab and context question and send it to us on the Discord, and I can pick it up once Brady's done or once Brendan's done and something like that. Brady, are you ready to do something for Vinroy? Because I'm finished up. Okay. Can we turn off the overlay too?
Yeah, I got it.
Lovely.
Lovely.
Also, anybody who hasn't been here before, welcome. We will answer your questions about anything. We have tests, ideally, that we can answer questions. Those are down below. It just makes it easier because we can put them on the overlay rather than having to explain to everybody your question. I'm done. You probably don't need this too much, but I'll put it over here.
So Vinroy, I want to hear a little more about exactly what you're wondering about. You're asking about systems of equations, how they work. Systems of inequalities, right. Okay, so systems of inequalities and how you solve them, I think, is what you're asking for. And if I'm wrong, please just chat give me a little message on what exactly you want me to do. Otherwise, I'm just going to dive into this, and you can tell me if this is kind of hitting the mark. So systems of inequalities, just like systems of equations, mean we have two. We have two lines. We have two equations, in this case, two inequalities. So I'm going to give us two inequalities. I'm going to say y, you know what? Different color. Different color. Yes, how do you solve for x with a system of inequalities?
Well,
I see. You
that's
solve
a
for a
weird
point.
thing.
That's the first thing.
Yeah.
A system of inequalities would have two variables in it, at least.
Yeah, you can't solve for one.
Yes. Okay, so Vinroy, I think what some of the trouble is what a solution to an inequality looks like in the first place. So if I were to graph this inequality, let's make it nice and easy. Y is greater than 4x plus 1. What this would look like is I would just graph this like it's a normal line, slope-intercept form. We have a y-intercept of 1 and a slope of 4. And I'd also make it a dotted line because it's not an actual equal to. It's a greater than. If it's that or if it's less than, it's a dotted line. If it's greater than or equal to or less than or equal to, then we have a straight line that's not dotted because you can actually find a point on that line. So slope of 4, we go up 4 over 1. You're looking at something that looks like this. So a solution. Oh, wait. No, Vinroy, no, you're not. Is this not what you're asking about? Or I meant systems of equations. Ah, okay, yes. I was going to say, for systems of inequalities, all you're going to get is a region that has points that satisfy a system of inequalities, and I think that you are probably hitting yourself on the head right now. Don't do it. Okay, you're fine. Systems of equations. That is a good question, as was this. So let's just get rid of what we have so far. Okay, there we go. A system of equations. So how you solve systems of equations? That is a very good question. And you are in the right place. You are in the right place. System of equations is two lines, okay? Where they intersect is what your solution is. So your intersection point is a point. It has an x and a y coordinate. It's not just an x value. It is an entire point, x comma y, that falls on both lines. Now, you can't always graph something. You can't graph it perfectly. It's hard. The equations that they give you probably won't fall on what's called lattice points, which is the actual intersections of like whole number units. So when you first learn graphing systems of equations, usually the answers are really, really nice points that are right on the lattice corners. But chances are in the ACT and SAT, they give you much harder ones where you get decimals and fractions as your solutions. So let's give us a simple system of equations here. Let's give us 4x plus 5y is equal to 7. And we'll say x plus 2y is equal to negative 4. These are in standard form right now. Standard form of a line looks like, in general, it looks like this. ax plus by is equal to c. And they're not as straightforward to graph as when you put them in slope-intercept form, but they mean exactly the same thing. So what I'm going to do for myself, because this is what I usually do, is I'm going to change this real quick to slope-intercept form, because when I can pluck out the slope and the y-intercept, it's much easier for me to graph them. So let's see. This would be, I'd move that over so I'd have 5y is equal to negative 4x plus 7, and I divide both sides by 5. I'm not actually going to graph this for you. I just want you to see that standard form equations are just like normal XY equations. They're just a different way of formatting everything, but they still code for some line on the coordinate plane. So this would be negative 0.8x plus 1.4. And we do something similar for that, okay? This is if you wanted to graph it and find that point of intersection. Let's not do that, though. We're going to use two different methods here to solve for systems. First method is going to be called substitution. So for substitution, you need, step one, to solve either equation for one of the variables. And it might already be solved for one of the variables. And if it's not, try to find the easiest variable in an equation that would be the easiest to solve.
Make sure this is exactly what he wants.
Yes. Is this exactly what you're looking for, Vinroy? How you can use substitution and elimination to solve for the solution to a system of equations? Because if so, I will keep writing, and you can just let me know on the chat. So I'm just going to pedal on forward here. Solve either of the equation, elimination. Yes. Okay, good. We are on the money here. So for this equation, the easiest variable that I spot, it'll be the least amount of time for me to solve. This x right here, it doesn't have a coefficient, or in fact it does, but it's 1, which means I'm not going to have to deal with that. So this one's going to be very easy to solve for. All I have to do to get this x by itself is to subtract 2y to the other side. So when I do that, I get that x is equal to negative 2y minus 4. Same equation, but now it's been solved for x, okay? So this was step 1. Step 2, I'm going to do in yellow. Step 2, this is why it's called substituting. Substitute whatever you got for that variable. In this case, we found that the variable x is also equal to negative 2y minus 4. So substitute in expression for that variable in the other equation. Because if you have an equation with 2 variables in it, you'll never be able to actually solve for either one of them and get a number. You're only going to get an expression that involves the other variable in it. So you can't really solve it until you have another equation altogether. That's when you can actually find a place where they both intersect. So I'm going to take this. I'm going to substitute it in for where I see x in the very first equation, which is right here. This x now has a new identity. I'm going to rewrite this equation, and where I had x before, I will put this new expression. So this will be 4, in parentheses, negative 2y minus 4. That was our old x, now it's this. Plus what we originally had, which is 5y, is equal to 7. What we have now is great. It's an equation with a bunch of y's in it, and that's it, which means we can actually solve for y. So both methods, substitution and elimination, which we're about to go over, get you to the same point. It's where you have an equation that only has one variable in it, which means you can actually solve, and that's the exciting part. At least I think it's the exciting part. I think Levi agrees with me. I think Brendan doesn't find this exciting. Is that right?
True. Brendan hates it.
Brendan, I don't know why you don't like that. So at this point, I'm just going to distribute, and I'm going to get y, all the y's on the same side, and just solve this because it's a normal algebraic problem. We've got negative 8y minus 16 plus 5y is equal to 7. I'm going to combine like terms, which means I have negative 3y equals, so I combine those, and I have to add 16 to the other side, which would be 23. All right. This is not going to be the best number in the world. Am I allowed? Let's see. Why does it turn from 2y to negative 2y? Let's see. Right here. This is why you're asking. Step 1 was to solve this equation right here for x. It's not solved for x right now. When it's solved for something, it means that that thing that it's solved for is by itself on one side of the equation, and that's it. So x needs to be by itself. X right now is not by itself because it has plus 2y on the same side of the equation. If you want to get rid of that, right, an equation is just a big balance. If you want to get rid of plus 2y, you have to subtract it. That is what will cancel it out from this side, but you have to do it to the other side as well. So if I subtract minus 2y from this side, I have to remember to do it this side as well. So here, these are going to cancel, leaving x alone, which is good. We want x to be alone and afraid and in an alley. And then never mind. And then we have negative 2y over here. Negative 2y minus 4. I was just confused since I didn't visually see the steps. I should have done that. My apologies. Negative 2y, this is the step right here. That's what you're missing. So that's where we got negative 2y minus 4. All right, I will make sure to put all of my steps. I'm doing some of them in my head, and I should not do that because you bring up a very good point. So now, what I did here, I combined like terms, and then I had to add 16 to both sides. I decided to make this left side the y side. I'm going to leave all the y's here because the y's are already overcrowding this side, so let's not move them to the other side. We're going to add the 16 to get it to the other side and get it away from this side. Let me know if you have any questions about where I'm at right now. At this point, I just have to solve for y, which means divide both sides by the coefficient, which is negative 3. which means y, I'll put it right here. Put it right here. Y is equal to, okay, this is going to be a fun one. I'm going to turn this to a whole number. It's going to be negative, because positive divided by negative is going to be a negative. 7 2/3 would give us that. So I will say 7.66. That's what I'll call that, okay? We now have what y is. We're not done yet, but we're really, really close, because we've actually triangulated where y is. At this point, you get to step 3. Plug in the newly known value and solve for the other variable. So we're going to plug in this value for y into either of the equations. I probably should have specified that. Known value. I'm going to say into the easier equation. Move over here for a sec. There we go. Because you a lot of times have these choices of which one should I try to tackle, which one should I move through to solve for a variable, and it's always just a matter of which one will be easiest, require the least amount of steps. Plug in known value into easier equation, solve for other variable. Okay, so I'm going to get rid of this. This is not important. That was just me showing you that this is an equation of a line that's slope-intercept, which you can visualize on a graph. I'm going to use this room now to solve for the other variable, which is step 3. I'm going to take negative 7.66, and I'm going to put it into either equation, whichever one looks easier. I'm going to actually put it into this equation here because this one's already solved for x, so I will have the least amount of work to do because I already did some of the work in the first place. I have x right now in terms of y, which means that y is on the other side, so I just plug this in for where y is, and then x will present itself to me. So, step 3 is in pink. Put it up here. X is equal to, we had negative 2 times y, which is now this number. Negative 7.66. How are we doing on the different colors, guys? We liking it?
Your parentheses are different colors.
Yeah, it makes it a little confusing.
Right here. Is this the only place where it's been like that?
Yeah.
Yeah.
So as I was telling you, or as I was asking you how I'm doing with colors, I screwed up the colors.
Yes.
Okay. I didn't mean to make this blue. I got overexcited because I thought you guys might give me a compliment. Because you guys normally starve me.
Ready, same one.
I'm sticking with it. I'm sticking with it. Now I'm committing. I'm committing at this point. It's too late.
Yeah.
Too late.
Oh, good.
No. I'm gonna do this the right way. Yep.
Brady.
You do not do a job halfway. All right? That's what Brendan's dad told me when I was young. If you're gonna do a job, you do all of it. You do it well. -4. Oh, this monitor's off. Can somebody jump on that?
Yep.
One of you two guys. I'm going to multiply these and just subtract 4. So this is going to be, let's see, positive 14 and 4/3, which is positive 15 1/3, which is 15.33, -4, which means x is going to be equal to 11.33. Now we have our entire coordinate. I believe that's right. 14 and then 15 1/3. Yes. Our entire coordinate is 11.33, comma, negative 7.66. That's how substitution works. Elimination is, the first part of elimination is what makes it different, and then you get to part 2. No, I'm sorry, that's still part of substitution. Part 3 is the same for elimination. Parts 1 and 2 will be different. It's a different strategy. Should I go through elimination, guys?
Why don't you let Brendan go up and then maybe we can come back to it.
Sounds good. All right, Brendan, come on up. That was substitution. That's part 1. It's one way to get you where you want to go. You can always use either one. It's just sometimes one might be faster because the two equations are already kind of set up for a different way.
Hey, Uncle Bill. He's not actually my uncle, guys.
Oh,
Uncle Bill Druin, that guy.
I think that's how you say it.
Can you give me a little?
yeah.
Oh,
I
that's
think so.
nice, 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 nice,
Okay.
nice, nice, nice.
Look at us. We do car washes on the weekend, right?
Yes, we do. Yellow, y'all.
Nerdish car wash.
It's like Jello, but with a Y.
That's exactly what it is.
That's probably why it says it.
Maybe.
Maybe not.
Yeah, I don't know.
Yeah, probably not actually. Considering I just made it up.
On the spot.
We're racing this together.
Yeah.
Yep. It's like Brennan's dad once said to me. It's worth doing with a team. You got to use your team to do what's worth doing.
With that team.
And I said to Brendan's dad, it's a little redundant. And then he slapped me. And I went up to my room.
All right.
Okay.
Can I have this mark? Okay. Thanks. Okay. All right. Brady. All right. We're going to be talking about data interpretation. Marker's kind of running out. Is this the bad? Why do we use this one again, guys? Come on. Okay, data interpretation. Boom, way better.
My leg? I was a little late. I was drinking water.
Oh, gosh. Okay, data interpretation. We're going to be talking about this. We went over this last week, so I'm going to go over it kind of quickly today. This is mostly for anybody who has questions on it. We're going to go over them. What we mean when we say data interpretation, if it's not clear, that's fine. It means being able to read graphs, charts, and tables. Not just being able to look at them and say, oh, this is what it means to be on the, this is the line it's talking about. It's being able to know what's on the x-axis, what's on the y-axis, and how they interact together. This can be, for any of you taking the ACT, this can be useful not only for the math, but also for the ACT most specifically, the science section. It is mostly data interpretation. If you are taking the SAT, it's useful in both the reading, actually, occasionally in the writing and language, and a lot in the calculator section of the math. However, we're going to go ahead and actually just jump right into some questions. Levi,
Yep.
Do you mind setting me up with the SAT, and we might need to flip back to math, or even just turning it on and I got it here.
You got it?
Yeah.
Okay. Wait, just like.
Yep,
Alright.
Thanks. All right. It's going to lag a little bit, guys. Apologies there. For those of you who want to follow along with us, we'll be going over question 1 when I get there on the calculator section. For those of you who want, you can go to this test down below. This is going to be SAT 3. We have linked down below. You can pull it up, and it'll be question 1 right here. Go ahead and actually erase this. Okay. Now, as many of you and maybe all of you know, when we start with the SAT, it's the same with the ACT, but a little more pronounced in the SAT. Question 1 is going to be the easiest question, and that's fine. Right now, we're just trying to get the very basics of this and understand what we mean when we say we want to be able to interpret this data. Okay? It says the above graph shows Marilyn's distance from her campsite during a 3-hour hike. All right? The full 3 hours are shown on the x-axis. Great, we now know the x-axis is dealing in time, if we didn't already know that. She stopped for 30 minutes during her hike to have lunch. Based on the graph, which of the following is closest to the time she finished lunch and continued her hike? Okay, we want to know when she finished lunch. All right, so that's important. Go ahead right here. When she finished. We know it looks like she started at noon and she ended at 3. It was a 3-hour hike. And then we want to really pay attention here to the y-axis, because what this is saying is the distance from the campsite. If we're assuming she's going on a hike, the distance she is from the campsite should be changing while she moves. Right? That makes sense. Whether she's going out and back or going around and back, it's going to be, the distance is going to be increasing or decreasing at all times that she's moving. Right? However, we have a period here where there is no change in the distance. All right? And if you look at that, it looks like it's about maybe 30 minutes. And we know that her lunch is supposed to take 30 minutes, meaning this should be the time they're asking for. However, there should be something we make sure we're clear about. This is when she finished lunch, not when she started. Now, the reason we have this is because if you say, well, she started lunch at 1:10, boom, your answer would be B, and you'd be wrong. Right? I underlined finished lunch because they're trying to trick you even on question 1. The answer is actually C. All right? The ended right about here, closer to 2 than 1, so I can say at about 1:40.
Well done.
Thank you.
I'm saying that to Vinroy.
Ah, okay. Well,
I knew you could get it right. I'm proud of Vinroy.
that's rude to both of us. Question 2, right? Just so we can get some experience with both a graph and a table. The table above shows the distribution of age and gender for 25 people who entered a contest. If the contest winner will be selected at random, what is the probability that the winner will be either a female under the age of 40 or a male age 40 or older? What we want here is we want to be able to say, what are we looking for? All right, the probability that the winner will be either a female, okay, so female is going to be this whole section here, all the way to here, all the way to here, and she should be under 40, right? So we want this column. Or a male, let's use a different color here, or we want a male who is 40 or older, meaning we want this, whoops, let's go ahead and get all of it, 40 or older. That pink is not showing up great. That looks better. All right, what we do from here is we say, okay, where are we overlapping? Right? I want female I want all the females under 40. That's going to be right here, so I have 8. Let me write it here. And I'm going to add that to the number of men who are 40 or older. It's going to give us 2. All right? And what we're looking at here is we want this amount, right? What is the probability that the winner will be either this number 8 or this number 2, so we can add those. And then we want to know how many people are there total. We want to have the probability, and we have 8 plus 2 is just going to equal 10, right? 10 people total. There's a chance that 10 of these people will fit this, or 10 people do fit this, and the total is out of 25, so we're going to actually divide this by 25. 10 out of our 25 people fit this description, so the odds are 10 and 25. Again, this is very straightforward, or it should be. If it's not, let me know. We can go into more detail on this. Again, question 1 and 2, they should be simple, and we will go ahead and jump into some more difficult ones real quick. All right, the next question we'll go over will be question 20. Great. I'll go ahead and erase this, give you guys a second to look at it, read the question. Try to do it before I do. All right. We have that Michael swam 2,000 yards on each of the 18 days. All right. The scatter plot above shows his swim time for, the scatter plot above shows his swim time for and corresponding heart rate after each swim. All right. The line of best fit for the data is also shown. For the swim that took 34 minutes, Michael's actual heart rate was about how many beats per minute less than what was predicted by the line of best fit. All right. I have some students who do not know what the line of best fit is. If you have a scatter plot, the line of best fit is ideally going to be given to you, not always, but it's going to be a line that is an estimation of what all these dots together would be. So if you took all these values and averaged them, this line would cut through the average of them. All right, it's the line of best fit, meaning it is their best approximation. Right? Now we're looking for the 34 minutes, right? All right. The swim that took 34 minutes, right here, we're going to go up, and we're looking at these, right? It looks like the line crosses at 150. And what we have for the actual point is one line down. However, each of these lines, something that is important to look for, to recognize when you're going over data interpretation, and especially on graphs, is how much they're increasing for each tick on the axis, right? If we look at the x-axis, we're going by a half every 2 ticks. If we look at here, we're going by 10 every 5, meaning every 1 tick is just going to be 2, meaning we're going to be a difference of 2. All right, meaning the answer here is B.
Well done, Vinroy.
The last one, we've gone over a couple of times in the past couple of weeks, meaning we're going to be switching tests here very soon. Kind of hits on a couple of different topics. It's going to be question 29. This one's a long read. We'll get through it. It tends to be difficult for students, mainly because there's a lot of different things you have to do here. All right. The incomplete table above summarizes the number of left-handed students and right-handed students for by gender for the 8th grade students at Kiesel Middle School. What's difficult here is you don't actually know all the values. You have to actually fill them out yourself. All right. There are 5 times as many right-handed female students as there are left-handed. Right? Meaning we have 5 times as many right-handed female students as there are left-handed. Meaning left-handed, we'll just say F for female. And the right-handed is going to be 5 times that number. 5 times as many. Okay? That's our first step. That's the first thing we have to do. We continue reading. There are 9 times as many right-handed male students as there are left-handed male students. Okay, let's go ahead and put M here. And we know that this is 9 times that. Great. This is the hardest thing for my students to figure out, is that you're going to use a different variable for each. Most of my students, if they mess this up, they get to here and they have x, 5x, x, and 9x. Not realizing that you're actually setting up 2 different equations here, right? To do that, you say that I have some number of female students, and I know that the relationship is that there are 5 times as many right-handed as left-handed female students. Again, I have a certain number of male students. There's 9 times as many right-handed male students as left-handed male students. Continuing along, if there are a total of 18 left-handed students and 122 right-handed students in the school, which of the following is closest to the probability that a right-handed student selected at random is female? Now, Vinroy, we're going to actually do something that is going to help you. We're going to do a system of equations here. We know that if we add up all the left-handed students, we should get 18. Meaning if I go F plus M, I should get 18. Also, I know that if I take all of the right-handed students, I can make an equation out of that. I have 5F plus 9M equals 122. Brady went and did substitution. I'm going to go over elimination with this. All right. What we want now, all right, this is the data interpretation part of this problem, is being able to figure out and fill in both parts of the table that are missing, right? And then being able to interpret that to say this is how that translates into an equation. From here, it is system of equation, solving for one of these, and then there's actually going to be a probability at the end. So it's not just solving for F and M, it'll be something at the end of that. Now, to solve for F and M, I'm going to go ahead and take this top and multiply the whole thing by 5. And you'll think, wait, can you do that? Absolutely I can. If I have F plus M equals 18, if I multiplied this by 2 and I said 2F plus 2M, that should equal twice this side, right? I just multiply both sides by 2. I can do that. I can add or subtract anything I want from an equation as long as I do it to both sides. That's how you keep them even. Meaning I can also multiply or divide both sides by a number and keep it the same. Great. I now have 5F plus 5M equals 90. 90, yep. What I want to do now, and Brady and I do this differently, I want to subtract these. Brady multiplies by a negative number and then adds. I like to do it by a positive number and then subtract. Gets the same thing, it just depends on what works best for you. I've seen students struggle with not multiplying everything by the negative and they have issues there. I have students who have trouble subtracting this. There's any number of ways to make simple mistakes. It depends on your preference. What I have here, though, is I have these f's cancel. I have 9 minus 5m, so I have 4m. And I have 122 minus 90, which gives me 32. Meaning m, and I'll go ahead and write this out real quick, Vinroy, m equals 8. All right? I'm not done, though. They're not asking for how many males and females I have, right? What they want, right here, which of the following is closest to the probability that a right-handed student selected at random is female? Well, I'm going to go ahead and actually look at this equation here. Let me get a different color. What I want to do is I want to say, well, I know I have this equation, and I know what m is. So I can say if m is 8, f plus 8 equals 18, f equals 10. Right? That does not look like an f. All right. From there, I simply substitute these numbers in, meaning I'm going to have 10, 8, 50, and 72. Right? Those are my numbers here now. And what I want is the probability that a right-handed student selected at random is female. Well, I have 50 female students, and that's we're looking at out of all of the right-handed students, so that's out of 122. Now, this is the calculator section. Plug this in. You're going to get the answer is A, 0.41. If there are any questions, let me know. Otherwise, that's all I have to work on in terms of data interpretation, and we can start answering any types of questions. Hey, bozos.
Yes.
You guys ready to come up here and answer questions?
I respond to bozo.
I know you do. So I said it.
Oh, I guess that makes sense.
Do you mind shutting that off for me, Levi?
No, it's old.
Thank you. Cuidado.
Cuidado.
You know what that is?
Okay.
Do you know what that means, Levi?
Softly.
Careful.
I don't know. What does it mean?
Careful.
No, it means careful.
Ah, very good.
Yes.
I guess you thought I meant it to say, hey, careful what you
Yeah, I
guess.
thought maybe I
I
was saying
just-
something bad. Okay. Ask us questions. SAT, ACT, Brandon's
personal life.
Woo!
Yay!
High five.
The Wheel
or
of Time?
anything else.
Ask us about Wheel of Time?
Yeah, what's going on in the Wheel of Time?
Well, no spoilers, but I'm about to finish book 3.
Can you guys show us systems of equations with where all letters have a coefficient more than
Yeah.
one? Oh, sure.
Oh, okay.
Yeah.
I got it. Yeah,
it's
I
all
got
you
it.
did.
2x plus 3y equals.
Ooh, 11. 11. Oh. What is it?
No sé. Pero
Just a
hay
little
algo
bit of
like
mouth
that.
crust.
No, es
Still there?
sí, es similar a la salsa de un pizza.
Oh. Oh, well, comí un pizza.
Nah, you want other
Eso
stuff.
básicamente.
Okay.
I feel like that's not really that secretive. Most people can speak Spanish, right?
What? I ate a pizza?
No, just in general, me talking about la cosa en tu cara.
I want to make nice numbers. I don't know why it's so hard for me. Let's say that.
Los dos, no?
Okay. Hey.
Sorry.
Hi. We're
Hey.
just letting you go, man.
Hey,
Okay.
hey,
Whoa.
Levi.
Here we can do a couple different things. We can do the elimination method or the substitution method. Now be careful. This is not set up the way that you'd want it to be set up for elimination because
He's
we have
being
x
tricky.
here and y here. Okay, so we can do this either way. I'm going to do substitution to demonstrate to you that you don't have to do solve with substitution, please. Yes, sir. Okay.
Substitution
Here
is-
I'm going to subtract x from both sides. So I'll write it down here.
Listo para
We'll
mañana.
have 3y equals negative 4 minus 2x. And then we're going to divide by 3 on both sides.
Well, so elimination is tricky for him. So
So
maybe we should. All right, you do this. I'll do elimination over here.
yeah.
Okay,
Yeah.
Orange.
I'm going to explain
I
this
will make
because
you
this is
guys
confusing.
some sandwiches. Do you guys want anything?
Wait, what am I doing? Wait, no, he did say substitution.
Yeah, he did.
You're gonna
He
make
did.
sandwiches?
Yeah. Oh, he's gonna do elimination. You're
Knuckle
gonna do
sandwiches?
substitution, so I can make some. You want a knuckle sandwich?
You actually
I-
just have a.
We
here?
talked about
On
this.
the left
Quiet.
side.
Oh, you would know this if you were speaking Spanish with us.
Sorry. Sorry, you spoke in a different language.
Did I get it?
Sorry,
I
you
don't
don't
know.
understand it.
Equals me too, actually.
Yeah, I know. I don't understand. French,
Negative
it's okay.
4 minus 2x over 3. So that's what y equals. And now we're going to substitute it in. This y will go in for that y, right? Y equals that, so we'll just plug it in there. Now we're going to have negative 4 times this whole ugly thing equals 5. Okay, now we're just isolating x here. We're solving for x. That's what we're doing. So I'm going to divide both sides by negative 4 so that we can get rid of this one. So we divide this by negative 4, divide this by negative 4. Now we have negative 4 minus 2x over 3 equals negative 5/4. Then I'm going to multiply each side by 3 to get rid of this 3. Now we have this, and I'll deal with that in a second. Now we're going to add 2, so now we have negative 2x equals, let's just do this real quick. Sorry, what did I say, add 2? Add 4. So we'll add 4, do this thing. This is going to be negative 15 over 3, negative 15 over 3 plus 4. This does not work out the way I wanted this to work out nicely, but I guess
Best
it
laid
doesn't.
plans.
Yeah. Vinroy, are you, let's see,
He's still on.
modding in 2 other, I don't know
It's
what that
just-
means.
Because he's a mod in a couple other streams, so he's lurking in this one.
Oh,
Thank you.
Okay, cool.
Uncle Bill, anyway. Now-
No problem.
Okay. Are you good with that, or do you want me
I'll
to?
keep doing the ugly stuff here if you want
Okay.
to keep going.
Vinroy. The trick to the strategy to elimination, we talk about recognition a lot. You want to recognize how you can make your x's cancel or your y's cancel. For me, I see that 2 and 3 are very close together. I want to find a common factor or a common multiple, right? Meaning I would have 6 between them, so I want to multiply everything up here by 3 and everything down here by 2. All right? What that ends up giving me, I have 6x plus 9y equals negative 12. This one I have negative 6x minus 8y equals 10. Now, I can add these actually. These will cancel. I will get, let's go back to orange. I'll get just a singular y.
Oh, that's lucky.
It's not lucky. I actually did it right. I forgot when I did it, when I plugged this y back in,
I
I
wasn't
didn't
talking
keep
to
the
you.
negative 3x.
Oh,
So that was my fault.
All right.
keep going.
Okay. You take this and we're going to add them. So 6 and negative 6 cancel. 9 minus 8 is just y. It's just 1, so 1y. Negative 12 plus 10, negative 2. That's y. I'm going to go ahead and plug that back into any of these equations up here. I like the first one. So we have 2x plus 3 is negative 2 equals negative 4. 2x minus,
It's okay, you didn't know.
I didn't know, that was the mistake. Minus 6 equals negative 4. Going to add that over. We get 2x equals 2, or x equals 1. Is that what you got, Levi?
I set it up so it should be 1 and negative 2.
Ha, hey!
Oh,
hi, Mark.
Take his.
Just different color.
Yeah, these pinks are kind of dying on us, guys.
Okay, so I was graphing this simultaneously, and graphing, if you don't have a graph, set up a graph paper in front of you,
Great.
it might be difficult to find exactly where they're going to cross, especially without a ruler. So this is actually where they cross, and if the lines were better, you'd see that that's where they cross. That's the real answer.
Brady,
Hey, I did my best.
your best wasn't good enough.
It wasn't good enough. Yeah. Reminds me of childhood.
This one goes
Not me, Watkins' childhood.
Walking child.
I had a great childhood.
Your father.
So we have x equals
gave me
1
this
here,
watch.
and then you'd plug it in
It's your
just like
birthright.
everything else.
We're gonna
Yeah,
not
so
continue
this,
that one.
Vinroy, is the
I forgot he's
3...
able to multiply the
Oh, I
equations.
forgot you were
Yeah.
able to multiply
That's
the
the
equations.
kicker.
Boom.
Yeah, it's so big.
But also
Huge.
do whatever you're comfortable doing. If you like elimination, then do that. If you like substitution, then do this. And sometimes even if you like something, it's much harder to do that approach just because of the way the coefficients work out. Or you can graph. This is way harder with
my colors here,
in general if
Don't
they give
do
you the
this
equation.
unless you have graph paper and rulers in front of you.
Mhm.
And then you can, even if you do, you're going to get something that's very, very close, but probably not right on the point, because that would mean geometrically you drew something that's perfect, and that's very difficult for humans to do. Unless your teacher tells you that they're going to be whole numbers, the answers, then you can trust that your lines
We'll get
actually
one good
meet
shot out of this.
in a good place.
Ta-da!
There
Okay,
it is.
now can I erase? I actually have something cool I want to talk about. Can I erase?
Yeah. Elimination is so much easier, Oth says. I think so. It depends on the equation, the actual problem you're dealing with. I tend to use elimination for most.
Yeah, elimination seems to make more sense logically. I feel like, wait, sorry. What do you say? Elimination is harder,
Easier.
easier. Oh, I disagree. But it is whatever you feel like doing.
Yeah,
Whatever
it's
is easiest for you.
different per person. Where elimination is hard to use, I mean, it's
Friendship.
always the same pattern. You're
You want
still
to eliminate a friend or substitute a friend? Which one's better? That's where
Depends.
it's hard to use.
depends. Do I need all those friends?
If you don't need all the friends, then that's when you start eliminating. But if you do need a certain number of friends, but one of them's got to go, you got to substitute.
Okay, I got you.
Qualities?
Here's
we'll get
elimination
there.
that's hard to use.
Nice.
Oh, no.
That's annoying to do elimination for, because why not just do substitution?
He's right.
You have y, you know what it is, so now you just substitute it in. And then you can find x. You get 2x minus 3 times 2 for y equals 4. 2x equals 10, so x equals 6.
One thing with systems of equations is that there are 3 possible outcomes of solutions. First outcome could be what we've been showing you, which is you got 2 different lines and they cross somewhere and there's an intersection point. Next outcome, if those 2 lines happen to be parallel, they will never cross, therefore you have no solution. I'll write that here. Brennan, what's the last one? This one's your favorite.
Is it?
You want to put it right there?
Yeah, I'm gonna use a different color and try to make you proud, Brady.
You make me proud every day.
That's,
Yeah,
yeah, I doubt it. Okay.
Stop it.
Or you have that they are the same.
They're the same line. One's just right on top of the other.
That's supposed to be just a really thick line that I messed up, but you get it, guys.
Yes. And so why would that make it? What would you categorize that as?
All real, all solutions. They are the same for all values of x that are equal to each other.
Interesting.
What is? Go ahead, Brady. For
Well-
what you were softball pitching it.
I would say infinite, and I wouldn't say all real though, because like this right here is not a solution. So that wouldn't be. It wouldn't be all real points. Would
For
be
all values of x.
for all values of x, the values of y match. Right. Oh, so there are solutions for all real values of x.
Yeah.
Yes. Yes. Okay, I get that.
Okay,
I
sorry.
get that. No. That makes sense. That makes sense. I'll throw that infinite or all real.
If
By
a line-
has no slope, do you mean so? No slope means you have something like here's your line. There's no that has an undefined slope. If you mean a slope of 0 where the line is like that, then then
yeah.
you can have the other stuff there too.
Yes. A
You
line-
can. This won't look like anything normal. This won't look like y equals
said
something
that.
x plus whatever.
Yeah, that's what he meant.
This would
Yeah.
just be x equals.
Auth-X
3.
gets it.
He gets it.
He
She
gets
gets it.
it.
Okay.
He or she gets
cool. Question for Auth and Vinroy, since you two are active right now. What test are you taking? If you're taking the SAT, I do want to give you a problem that I think is pretty interesting and simple, actually.
But is it useful?
SAT.
SAT.
Ooh, lovely. Okay.
Wait,
so this is
Vinroy.
Yes.
Yeah,
Yes.
hear about
Well,
Vinroy.
I'll still answer the question. I'm gonna give it anyway. ACT and SAT.
Oh.
Very nice.
Whoa.
Very special.
That's it.
Okay. If we have the equation y equals 3x minus 4, and then we also have the equation 2x minus 4y equals 1. And I say, I lied. We're going to change.
You say you lied or you
This.
did lie?
Did you lie about saying that you lied?
Yeah, I mean, which one is it? Because that was a little confusing.
Don't know.
The statement is false.
For what value of a does this system of equations have no solution? Now, when we're trying to figure out no solution, bummer. Let's think about these graphically. If you have one solution, there's one place where they intersect, which is the first thing that Brady drew here. Just call it up in your mind. Was right here. They intersect at a point. But now, there's, let's see.
I'm not sure if I understand that all the way.
Yes, that's true. You could figure it out that way to try to make it not work. Or you could actually do it without even working all that hard. Put both equations into y equals mx plus b form, and I'll show you why. So we already have that one. And then let's do this one. So we're going to, let's subtract ax from both sides. And we get, I'll just do it here, negative 4y equals 1 minus ax. And I'll switch that one around. But then we're going to divide by negative 4 and divide by negative 4. Now we have
What's gonna
y equals
You
a
put
over
money on it?
4x minus 1/4. Okay,
Money
so
on it.
we have y equals 3x minus 4 as well. Here
I
are
didn't
our
hear what you
two
said.
equations in y equals mx plus b form. For these two to not have a solution, that means they won't be the same line. They have to be parallel. If they're parallel, they never touch. Therefore, they have no algebraic solution. So all we need to do is take their slopes and set them equal to each other. Because if they have the same slope and a
What?
different y-intercept, they'll never touch.
He's kidding, right?
All we have to
That's
do is
impossible.
a
No.
over 4
They said it
equals
couldn't be done.
3.
Is he doing it?
So
No.
a
No.
equals
Don't do it. Careful.
12. That is the
That's a
value
fancy
of
looking
a
too. You
for
think you're
which
better
there
than
is
us?
no
I think you-
solution
better than us?
for
Yeah.
Because you're 12?
the system.
Yeah, your
Think
12
you're
is really
fancy?
fancy. You're a fancy, fancy 12
Dang,
guy.
that is so much easier.
That's what you are.
I agree. I think it's a really pretty way of doing it. That's why it's so important
good
to
way to
have a connection in your head between the algebraic way of solving things and the graphical one. If you have one equation, if you have one solution, that means you have one intersection. If you have none, they're parallel.
How many interceptions do we have?
None.
Just so you guys know, two lines that have infinite solutions would look something like this.
For anyone who's just joining, feel free to ask any questions you want to, any questions on any topics you want us to cover. They can be specific questions, anything from ACT, SAT, strategy.
These
Let us know.
here would have infinite solutions because they're essentially the same line. One of these lines is just a multiple of the other. So you could simplify this. You could divide all these numbers by 2, and it would turn into this line. So these two lines are on top of each other the whole way up and down through infinity.
So if they were off, how to look for if the question was what would be the value of AX if there was only one solution?
As long as it wasn't 12, you'd be fine.
Yeah, it could be
Everything
almost
except
anything.
12.
Any real value aside from 12, because then
Yes.
they would not have the same slope. They would eventually intersect.
Yeah. Because they're not starting at the same point, they don't have the same y-intercept.
Just keep going, man.
Any value works except that. Yeah, erase that one.
Any other questions? We are here for you. And you're here for us.
I like that thing because it's a question that people find really, really difficult, and it just gets so simple,
If you visualize
and
what
you
they're
don't
asking.
really need to have super in-depth knowledge of it. Just
Correct.
connect graphing with algebraic solving of systems.
A lot of this. You're looking for connections. Interdisciplinary. That's a good word. Except it's all math, but it's within the disciplines of math.
Yeah, graphing and algebra.
Yeah.
Ah, okay.
Yeah.
All right.
Any other
If
questions?
you guys got any questions, let us know.
Let us know.
We've already
SAT?
covered our topics.
ACT, Brandon's personal life.
You guys haven't asked yet. There's so much to tell.
Is there though?
There really is. There's
There's
lots
so
to
much
tell.
we
Yes. Me and Levi just talk about it all day.
Question 40 of the ACT from you guys.
Yo, I got this.
Oh. Uh-oh. He's pulling it
I
up.
gotta turn this back on.
Yes, you do.
Blast. Well, since we're pulling up the overlay, I'll get off since I just did the last one. One of you guys can do whatever it is.
Whoops. ACT question 40.
Think so. It's gonna lag a bit.
Yup. Brad, you don't want it?
I don't know. Depends what it is.
Oh, absolute values. I did these the other day. I got it.
You want it? Oh
Yeah. Don't even worry about it. Don't even sweat it, guys. Okay. Vinroy's asking for question 40 on the ACT. We have this test link below. That's what we meant by the one we have. All right. The equation, absolute value of 2x minus 8 plus 3 equals 5, has two solutions. All right. Those solutions are equal to the solutions of which of the following pairs of equations? We went over this a little bit the other day. I don't know if it was last week or just earlier this week, but you can go and check out our video where I cover this all more in depth and actually go over this question specifically. But just for this one, Vinroy, let me know what question you have specifically about it. I'm just going to go ahead and solve it like I would for any other absolute value equation. What we know if this is an absolute value is it's the distance. The value in here is actually the distance from 0, meaning the value in there, when we have the absolute value of it, it's going to always be positive when we pull it out. What that means is, if I had the example of x equals 2, right, the absolute value of x equals 2, I could actually have that x equals 2 or x equals negative 2. right? Because the absolute value makes it positive, meaning both of these values would work. All right? So, if you see the pattern here, I've just taken off the absolute value and written it twice, and I take the opposite of this value, right? The negative of that value. I can do that with this equation as well, and I'm going to. First, though, I'm going to go ahead and take this 3 and put it on the other side. I'm going to subtract it over. Meaning I'm going to have the absolute value of 2x minus 8 equals 2. Right? I subtract 3 over. From here, what I want to do, let's see if I can't fit this in with the other color. I have 2x minus 8, and 2x, good, fits, minus 8 equals 2 and equals negative 2. All right, like we said, this is the distance, so we're taking whatever value this is and making it positive, meaning this value could be a positive 2 or a negative 2. The absolute value is just going to give us 2. Looking at these, the only ones that look like they have a 2 on the other side are going to be K and G, meaning F, H, and J are just wrong, right? We know that here. We can get rid of those. But now, G and K both have positive 2 and positive 2. Okay, one way I can get rid of this negative, I'm going to go ahead and write this here. I can actually get rid of this negative by dividing by a negative 1. Meaning, I'll just go ahead and say it's negative 1 times 2x minus 8 equals 2. All right. And this, saying that I have now these two equations, I look, and that looks exactly like K, right? They don't show that it's a negative 1, they show it's a negative. And that's how you would find the answer. Vinroy, let me know if that answered your question, that helped you out. Let me know if there was anything that wasn't clear there. Anyone, really, if you have any other questions about this or on the test, feel free to kind of scan through them. We can do any questions on any of them. Thanks, Levi. Let us know, and we'll gladly go through those with you. Jitterbug or something?
Huh?
Why does... Okay, so...
Wait, should I...
No, you're good.
Is that not the overlay anymore?
It's fine. It's the same thing. So we had the absolute value of 2x minus 8 plus 3 equals 5. All right? Now, you can treat these in terms of PEMDAS as parentheses, meaning I want to... maybe not parentheses because you don't want to do them first in this case, but I treat everything in here. I do this all before I take it and do what I did where I have this. Before I get to this step, ideally I want to get this on its own, right? Otherwise this 3 can be confusing. All right? What I did was I just subtracted the 3 from both sides. Whoops. 2. And then from there, I know the distance is going to be 2, meaning it can be a value of 2 or negative 2, and that's why I set it equal to both of those.
Question for you, Vinroy.
Great. Doesn't want to erase well.
Okay. Given this function, or this inequality here, what do we know about the value, or what can we tell about any of these variables here? Do we know that A is less than or greater than 0? Same thing with C, same thing with F.
Ooh.
Why don't you give this one a shot? You have...
Yeah. Take some time.
This long.
If anyone has any questions, let us know.
Yes.
I'm going to switch your spots real
I
quick.
just thought this would be a fun
This is a
absolute
good one.
value one.
Yes, you have 3 units of time for this. If you're
Yes.
wondering how long a unit is, take the amount of time we're about to give you, divide it by 3, and that's 1 unit of time. You have 3 of those. Yes, I just said a unit
time's
of
up.
time
I think
is
time's
equal
up.
to itself.
No, I got
sure.
it, I got it.
Okay.
You're not wrong. Okay. In this case,
Yes.
that thanks was not for this. Nope.
No.
Looks like we got radio
That was
silence
for me.
on the side of chat.
Yeah. Let us know if you have any other questions. We can keep going over absolute value. We can cover...
Wait, did you say
Any topic.
radio silence?
Radio silence.
I think you mispronounced that first word.
Bradio silence.
Radio silence.
I'm glad you said it to him and not me because I was still lost there. I'm sorry.
Took me a while.
You guys
I don't
will
know
get
this
there.
one. Yeah, this one is hard. You have a bunch of variables. How do you know what's going on? Well, you know that this whole side is less than 0, and that's great. But what else is here
So-
that you know always happens?
Authex, we're trying to see which of these is true. If this is our
Yes.
given equation.
Yeah.
Are we sure of any of these? Possibly none, possibly all. Although it's not all of them.
Yeah.
Okay. In this case, what we have to notice is that we have absolute value. And you know what absolute value does. It makes whatever's inside of it, it takes the magnitude of it, the distance from 0. In this case, this would all be positive, which means now you have A times some positive number. So I like to do it like that, is less than 0. If this is the case, A times a positive number being less than 0 requires that A is less than 0 because a negative
gotta
times
be.
a positive is negative.
It's got to be.
That's how this works. You should be able to recognize that this is the type of problem you're doing. This is what do we call it? Number theory is how we categorize these,
Yeah.
right? Number theory, logical reasoning problem, something like that. It's not a normal one, but you generally can tell when it's inequalities with a ton of variables and you're not graphing or solving it or anything. Can you do more of these? I can. Yeah, I can do.
I can do one.
You got one?
I would like
Go
to
for
do
it.
one. I will do one now. They also can do absolute value inequalities, which might be something we should talk about.
This?
They pop,
Yeah, but with something on the side where it's
when you graph it. Well, you graph it
Oh.
on a single dimension number line.
Got it.
Okay, here. We'll do one more algebraic one where we just solve it. Okay.
Oh, you're a lefty.
Yes, I am. But to
works for
them, it
me.
looks like they're righties.
For now.
Okay, and we're going to say plus 6 is equal to 10. Easy. Okay, your first step, isolate the absolute value quantity. So this guy right here, I'm going to circle it. I want to get this thing by itself. You could think of this, if you wanted, as one big variable like y. All right, so just to show you, I'm going to rewrite this equation where it's y. Is that overkill?
He's going off the rails.
I think he gets.
We
it.
want to keep this thing together. We want to get rid of everything else, okay? So if you had like 4y plus 6 is equal to 10, the first thing you'd want to get rid of is the 6. You'd subtract 6, different color. Subtract 6 from both sides. We get 4. Absolute value of x plus 3 is equal to 4. The next thing is we have a coefficient. If this were kind of thinking of like a variable that we want to solve for, we got to get rid of our coefficient by dividing by it. So divide both sides by 4. The 4's will cancel out, making 1. So we have x plus 3. The absolute value of x plus 3 is equal to 1. Here's the crucial part. The thing on the inside, consider that one big blob. That big blob can have two identities if this equation is true. That big blob can be positive 1, so that when you take its absolute value, you get positive 1. That big blob could also be negative 1, because then if you take its absolute value, it's going to become positive 1 regardless. So that creates two different equations, and you want to branch it out. At this point, you branch. So you first solve for the absolute value expression, and then you branch it, setting it equal to the positive version of what's on the other side, and the negative version of what's on the other side. And then you solve both of those equations separately, so you get two answers. So I'd be subtracting 3 from both sides for both equations. And I would be getting, Levi, what would I get here?
What?
If I subtract 3 from both sides.
4.
No.
What?
What about this one?
Negative 2.
And?
Negative 4.
Negative 4.
Sorry.
Negative 2 and negative 4.
I was wrong.
Put him on the spot.
Yeah.
You can't expect me to know how to do that.
Yes, I can.
Yeah.
I can thoroughly expect you.
Okay.
Fair enough.
Yeah.
Vinroy, was that helpful?
Hope it was helpful.
I want to do this one. I want to do
Go
this
for
one.
it.
Oh, that
'cause
was
we have
kinda
no
We're not
fun.
stopping you.
Yeah.
Okay. Let's erase this. I have
Yes.
it here.
I kind of want to erase his stuff.
Yeah, would it be fun?
Yeah.
All that work he did?
All that work.
I know what it
For
is
now.
now. Okay, so before I'm not going to erase this quite yet, but we're doing this one. So this is the given, and then which one of these 4 lines is must be true. I hope I did it right because I just made it up. It might be
Must
wrong,
be true.
but I think it's right. Could have made a mistake, but that's why we have you two and everybody
Yes.
who's willing to jump on my mistakes.
That should be every
Outside of
single
YouTube.
one of you.
Yes, please always point out our
If you can
shortcomings.
prove us wrong, this is the one time you get to be insulting in our chat.
You get to watch this for free if you prove us wrong.
How about that? Think about that. Not gonna break the bank anymore.
Okay. A plus B over A is greater than 1. Okay, so first of all, we know it's positive, so that's good to know. But that doesn't help us too much because we're comparing ourselves to 0.
How'd he do that?
I don't know.
So now we're gonna.
He has donated bits, so it wasn't completely free.
Sweet.
We appreciate it, though.
bits.
We might. Do we get bits?
No. He said he's watching for free, and I said,
Yes.
I don't know. You donated.
How did?
How'd that
Althex
work?
must be a hacker.
He must have applied to watch us.
Oh, he applied.
Yeah.
We're not-
Yeah.
I think
They let
he
him
must have
through.
applied
They
to
let him
watch
or her
us.
through.
Okay. I think this step. I don't know actually if there's another way to do this problem. But
Yes.
what I would do.
That's adorable.
Jeez.
It might be.
Is I would split up this fraction. So A plus B over A is the same thing as A over A plus B over A.
Wait, you can do that?
Yes, you can do that because if you add these together, you just get A plus B over A again. So here, A over A is 1. It doesn't matter if it's positive or negative. We don't have to know because if it's negative, it's going to be 1 anyway. So this means 1 plus B over A. And we're saying that it's greater than 1. Okay, well now the 1's cancel, or you can subtract 1 from both sides. We'll do it that way. We have B over A is greater than 0. Now we're back here. Now we say, does A have to be greater than B? We have no idea. This is division, so that means positive and negative gives you a negative and all that stuff. Same as multiplication. So A is less than 0, B is greater than 0. So that means you have a positive and a negative. That will be a negative, so that's no good. Same thing with the third one. The fourth one is correct. If both of them are negative, then you have a negative number over a negative number is greater than 0 because that's positive.
Yeah.
This is really, really challenging. This is a logical leap that I think you have to make. I don't know another way to necessarily do this problem aside from trying to find counterexamples. If you say A has to be greater than B, well, not really, because A could be, does A have to be greater than B?
They both could be negative.
They could both be 2, and then you have 4 over 2, and that's greater than 1, so
As
that's
long as they're
fine.
the same sign. You're
Or
okay.
then that doesn't work for this. So coming up with counterexamples is one way, but also this is I think a pretty interesting step going from here to breaking up the fraction. You get 1, but this is only for some of the very hardest problems. More on the ACT I've seen
Yes.
this type of thing. Okay,
Any other questions?
but I'm already watching for free. Yes,
Yeah,
we
already talked about that.
we already talked about it.
Yes. We're hungry for bits.
Speaking of,
No.
if you do
have
have an Amazon Prime account and you're watching us, you can
Oh.
subscribe for free.
Vinroy is sending us a question through Discord.
Lovely.
Discord.
The emphasis was so...
Disco RD.
All right. For those of you who don't know who are watching, we have a Discord down below where you can post questions that we will cover on stream. We will answer during the day if we see it, or we can cover topics in our streams, really whatever.
Yeah.
But we'll take everything into consideration. So if you are joining us late, the first 30 minutes to an hour every session, we tend to go through almost as if it were more of a lesson. A class lesson has more structure than now, where we're just letting you guys ask us any random questions. But if you give us ideas, we will add those to our schedule down below.
Make him stop.
Stop.
I don't
Okay.
have the technology to make
What
him
do we got?
stop.
Do we need to write it?
Lycanthropic virus, like werewolf, yeah.
Okay.
Is really nailed down, says Giles. The epicenters that have been mapped over thousands of years are likely the spots where werewolves are concentrated. As used in this line, concentrated most nearly means.
Yeah. I
This
see.
is pretty specific.
This is a vocab and context question.
Mm-hmm.
Yeah.
Can you guys see this?
yeah.
Can you see that? If you
Just
I'll
zoom
a
in
bit.
there. Yeah.
There we go.
Do that thing they do in the cartoons where they hold up binoculars and then you see their eyes kind of come out of the ends of them.
Mm-hmm.
You'll be able to see really far.
Yeah, this is difficult. The epicenters that have been mapped over thousands of years are likely the spots where werewolves are concentrated.
It's gonna go dark in a second here if you don't. Okay. What are the answer options?
Concentrated, extracted, paid attention to, gathered together, directed to one topic. Well, we are mapping over thousands of years epicenters. I think epicenters is if you don't know what I'm reading, I think the best thing to do is look on the Discord. Vinroy just posted it. and you'll see the sentence there. But they say the epicenters that have been mapped over thousands of years, yada yada yada, are likely where werewolves were or are concentrated. Well, we have concentrated, and then they are concentrated in epicenters. Epicenter means the very center of some grouping of,
Think about an earthquake.
in this case, werewolves. So extracted, no, because that's taking out. That doesn't make sense. Paid attention to, no, we're not paying attention to anything. Gathered together, that seems pretty good. And then directed to one topic. Directed to one, and then if it said place, maybe that would be a better answer, but topic doesn't have anything to do with it. Oh, great.
All
Congrats
right.
on Twitch Prime.
Hey,
I don't know.
Arthax.
Thanks, Arthax.
Very good. Very good.
No, don't
I
break
think he's
don't break the
purposely-
microphone.
It's too
He
late.
purposely
Should
didn't
I?
do it.
We'll
Maybe.
just
Well,
I'll think about
we'll
it.
think about
Okay,
it.
okay.
That's
Yeah, yeah.
upsetting, but all right.
thank you for the sub.
Yeah,
we appreciate it.
Yeah, we do.
Okay.
Any
Does that
other-
make sense? Also, whoever asked that was that.
was Vinroy.
That was Vinroy. Okay. Yeah, that's vocab and context. So it's not about necessarily knowing all the words, although it hurts if you don't, and it helps if you do. And then, good choice. It was a good choice.
Thanks, Uncle Bill.
Yeah, Uncle Bill. He's always there
not
for
my
us.
uncle, but I like calling him Uncle Bill.
Yeah.
It's a good name. It
You
just
don't
kinda rolls
actually
off.
know.
You know, Uncle Bill taught me how to throw a pigskin.
I
did.
bet I can throw this steak over those mountains. Anyway, you
Yeah.
weren't ready for that. Tina.
Okay. Can we talk about garden path
the
sentences?
Eat the food.
I want to
Yes.
talk about. Okay.
Yes.
Use Mags.
This will not help you.
Is that before their time?
want to use her chapstick. What does he say about their chapstick?
My lips are real bad.
Yeah, my lips are really bad.
The old man, the boat. Is this a grammatically correct full sentence, independent clause?
Doesn't seem like it, Levi.
Yes, it does.
Wait, really?
Where's the verb?
We need to define where the verb is. For
Vinroy
this-
says nope.
He says nop.
He
actually.
says nop. It's different. Nop is one of those intermediate answers.
Yeah.
Am I that much younger than
No
you guys?
problem. So in this case, you'd think that that the adjective is old, and old describes man, but it's actually this
However.
is the subject.
We're talking about the old,
The old,
This
like
is
it's
the
a way
old
of saying the
people.
old people, the
Yes.
youth, the youths,
not the
the
youths.
the
The
middle-aged,
elderly?
right? You might say the middle-aged,
Yes.
right? The middle-aged,
Well,
and
Or the
then
elderly.
yeah.
we have a
My
verb
parents are middle aged.
here. So man the sails, man the
Yeah, they're
oars. That's I think
fairly
is there another use of man that is not sailing related? Because I can't think.
Man
of
the lifeboats.
Yes, exactly. So anything that's not
The-
sailing related.
What?
Man the fort with forts.
Yeah, yeah.
I'm gonna
yeah.
man the fort.
So the old people man the boat.
Yeah.
It's not the old man, the boat, and you just have two subjects and nothing else going on.
Yeah.
So that's what this is. It's a garden path sentence. They won't do this to you.
They're just for fun.
But it is.
So why are you confusing them with this? Levi?
I like it a lot.
He hates
and
that.
I think it's funny.
Finroy hates it.
Hate is
Wow.
a strong word,
Levi.
but I really.
Do you
really,
hate
really
it in
dislike
the in the positive way of that word?
like that's bad or like that's bad?
Yeah. Well, yeah. Yeah.
Still too old? I don't know. All right.
Is it sus? I learned that word.
SUSS.
You feel
Uh,
so cool.
I don't feel cool. I feel really dumb saying that. Actually.
Positive, yes.
In the positive connotation, you said?
Apparently.
Hip hop.
All right.
Yeah. Nice to know now. Yeah, good. I mean, honestly, it is just a way to practice identifying your subject and verb. Because if you can't identify the subject and verb, then you're cooked. Cooked.
Like a steak.
Cooked like a steak.
A steak that is cooked.
Like a kosher steak.
Yes.
A good kosher steak.
All right. If there are any other questions, let us know. We're going to be hopping off in about 10 minutes or so.
They're wise.
We could sing a song. I'm just saying we could. I'm
We
not saying
could.
we will.
Yeah, I mean, we'd
a
have
very
to get a
low
really good request
probability.
and it'd have to be a song we
You
want.
still
song.
have a little bit of...
Stop.
Let me
Don't
do
get
it.
that.
Let me
No.
do it.
Bro.
Stop moving.
All the powder's gonna come off.
Oh, the powder's.
What
Yeah.
powder?
You know,
Oh, on your head.
Oh.
on my mask. You don't want to see what's underneath.
Yeah, we're riding on glass.
Bones.
We're going to keep that going every time we wipe your face. Yes, it's glass, so I'm not actually going to touch it because it's dirty. but
It's actually what it is the camera lens. We're just writing on the camera lens.
we're kind of actually
really
trapped
small.
in this glass
We're very
case of emotion.
We're very, very small people.
Yes.
We're
Please help us. Tell someone.
The Rick and Morty where it's the call
Yes,
this
yes,
number.
yes.
All right, now you see the little latch, open it, and they just run out. We're free. You don't get it because you don't watch it on TV.
I love
tonight.
that. That's
I
one
would
of my
like
favorite
that.
moments of Rick and Morty.
I would like that show if they didn't yell the whole time. It's just very stressful when they're always yelling the whole time.
Exactly, because they're universe adventures are pretty stressful. There's that one where they just start screaming when they come home from an
When are you guys
adventure.
going to do a giveaway with those tie-dye rags?
Well, funny, if we washed them, they wouldn't be.
No, I've washed them. They do not change.
Oh, so they stay like this?
And
that's good.
they're also not tie-dye originally.
They're just,
Yeah, they're not. We made them that way.
Rags.
But
if you want us to give
we
away
can give 'em
garbage,
away.
I
Yeah.
guess
Yes.
we could do that at some point.
Yeah.
That'd be a good idea. Thanks, Vin.
I have a half-finished, sandwich upstairs we could also give away if we're just throwing stuff out.
Yes.
Hey, if they-
Brady normally puts his gum in them
I guess I
right
could
before
stop.
stream.
Yeah.
No, I mean, kids
Stop
like
chewing gum,
Where
or
am I
just
gonna put my gum?
like the trash can would be great
Yeah.
for starters.
Where is a trash can?
Right on the other side of the glass that we're
Is
trapped
that what
behind.
that is? Well, we're trapped behind the glass.
Actually,
Anyway.
behind which we're trapped.
Stop it.
I'm just saying.
Look,
You know, it'd be a cool effect if we somehow had water start to rise on this glass. You were kind of like
it's
way
actually
deep in
would not
water.
be terribly difficult
We
to
could
do.
figure that out.
No, it's too expensive.
That's actually not. Well, we'd have to
All
buy
right,
another
thank
sheet
you,
of glass.
Vinroy.
Yeah.
Question. I got it. You got it? No, Brady's got to do one.
Oth posted a question on the Discord
My
as well.
thumb flap.
Okay.
You wanna-
I'll
do
check
it.
out the Discord. Bird,
I'll
you
do
do
I'll do this
52?
one.
Hip hop.
Got it.
52.
Oh.
System of equation. Do you need this though? I'm just gonna put
No,
it
I do
down.
not. You're right.
Okay.
And then Oth, we're getting to your question right after this.
52. You're given the following system of equations. Y equals x squared. Rx plus sy is equal to t, where r, s, and t are integers, meaning whole numbers. For which of the following will there be more than one solution with real number coordinates for the system? Okay, we've been talking about systems a lot today, and we've been using linear lines for them. They don't always have to be linear. A system is just two equations. And helping you visualize this on a graph will be helpful. That's not a great sentence, but you're going to want to think about what these things are going to look like. Okay, so this first line right here, y equals x squared, that is a parabola. It's just a simple parabola located right at the origin is where it has its vertex. I will put it, I'll just make a little picture of it right here. Okay. It looks like that. Okay? The other equation is the one that we know is linear. We have an x and a y and then a bunch of numbers, but we have no idea where it is. It could be anywhere. It could be up there, it could be over there. We just don't know. Normally, when you solve a system of equations, you can use substitution or elimination. In this case, elimination is not really... I suppose you could use elimination here, but it's not really going to get you... It's going to be confusing where it's going to get you. You want to use substitution, mostly because the first equation is already solved for one of the variables. All right? First equation is already solved for y. So I'm going to take what it's equal to, x squared, and I'm going to plug it in for y in the other equation. So our two equations here, we have y is equal to x squared, and we have rx plus sy is equal to t. So if we perform substitution, we're going to take x squared. We're going to plug it in for y, which is right here. So we're going to have rx plus s, x squared is equal to t. And this is not a great x. Okay, so we have an x squared now. And remember, r, s, and t are just, they're coefficients. They're numbers. They're just constants. Those are all kind of almost the same thing. Really, our variable is x, and we have an x squared, and we have an x, which tells us what we have here is a quadratic equation. A quadratic equation with constants that we don't know. Whenever you graph a quadratic equation, whenever you even deal with one, you always want to turn it first into standard form, which means get everything onto the same side and get it equal to 0. So this would turn into sx squared plus rx minus t is equal to 0. All I had to do is subtract the t to get to the other side. So this right here is the standard form. A quadratic equation will only have more than one solution if it has two solutions. There's three possibilities. No solutions, one solution, or two solutions. And the way that you can tell is the discriminant. The discriminant is the part of the quadratic equation that's under the square root, which, if you remember, right here. No, I'm gonna restart it right here. This right here, as you remember, is quadratic equation. The thing underneath the square root is called the discriminant, and it tells you how many solutions there are going to be. If the discriminant ends up being positive, there's going to be two solutions. If it's 0, there's going to be one solution. And if it is negative, there's going to be no real solutions. So if we want this to have multiple, we want more than one solution, which means really two solutions. Thanks, Levi. Whoa, there we go. then this discriminant is going to have to be positive. And if we think about what our a, b, and c values are, a is the coefficient of x, which in this case is s. B is the coefficient of just x to the first power, which is r. C is equal to negative t. Put that all together in the discriminant form, which is b squared minus 4ac. In this case, we'd have r squared minus 4 times s times negative t. So if I just distribute the negative, I have r squared plus 4st. That's the value of the discriminant. If we want the discriminant to yield two solutions, it must be positive. So right there we have our inequality that would make this have two solutions, which is going to be, it looks like F, which is right there.
All right.
Good question.
Thanks. All right. Authex actually has a really cool one. I like this.
I doubt it.
I'm hopping on it.
I'm kidding.
All right. Levi's going to come up and
I don't
draw
doubt
it
it.
because he's more artistic. I don't know. It would look pretty bad if I did it. Okay. He's going to write it up. I'm going to write the
You want to erase?
kind of
Well,
limitations.
okay.
Oh, no.
So we've got a cycle like this.
Couple of cycles.
Wait, that's not a very nice cycle. We got a cycle like this. And then we got a little cycle
A little.
like this. And I think this
A
one
little.
and this one,
A, B, C.
A, B, C. Okay. This is cycle A.
Yep.
This is cycle B.
Mm.
This is cycle C.
Yeah, now what are the radii?
And what do you say about the cycles? The radius of cycle A
What'd you call it?
is
Cycle.
7. Is
Seven.
it 7?
7 and fall
The radius of cycle B
Very good.
is
is
4.
4.
And we don't
What
know.
is the radius of cycle C? Brendan.
Okay.
How do
well,
you
there's
figure
something
it out?
else,
Oh,
something else you gotta
also,
tell 'em.
And the
Angle?
No.
The measure of angle?
The measure of angle. The measure of angle A, B, C equals 90 degrees.
All right.
Oh, no.
Thanks.
Yep. Right.
Now, what I want to do here, cuidado, careful. Something we say, most times we have circles. One of the things you can do, right? Something you want to try to recognize here, or just something to know is a good strategy. We want to be able to draw radii, right? They will help. However, you need to have an idea or, some intuition potentially behind where you want to draw these radii. We know that we have a 90-degree angle here if we were to draw a line from here to here and from here to here. Conveniently, this is the radius of A, the radius of B. Convenient meaning this is how it's supposed to be solved, but it just works out this way. We have this being the radius of C, and it's 90 degrees. What I want to do now, well, this looks like a triangle if I just take this right here. Ooh. Go ahead.
I'm just adding more of what the problem said.
Okay. And we have this line here. So this is also radius of C, radius of A. What I want to do now is I actually have a right triangle. What is okay? Lots of things that are nice to know is that with right triangles, you have a couple of things that you should know. One of them being the Pythagorean theorem. And I can actually use that to solve this.
Oh, yeah.
Yeah.
Cool.
All right, he gets it. You would have 7 here. You'd have I didn't realize the radius. Yeah, 11 squared for this side. 4 plus whatever this is. We're going to call this x and x, right? 4 plus x, that's squared, equals the radius of 7 plus x squared. Yep. There you go, Authex. From here, you would FOIL these out, solve, and you would get x. You get the value for x. Yeah, Uncle Bill's right. We have lights surrounding the glass pane to make this pop. I guess I can go ahead and solve this real quick. 16. These will cancel. I have, what is this? Well, okay. We'll do this a couple steps at a time.
Ew.
Yep, 121, 131, 137. Oh, this isn't that nice. Okay, minus 9, 128, 98, 88, 98.
98?
It'd be 88. Right?
Yeah.
Then you divide by 6. Is that simple? Is that something clean? Yeah, 13.
No, it's 78. This is not simple.
78?
Yeah, 78 divided by 6 is...
Why is it 78?
No, it's no, I'm saying 88 divided by 6 is not 13. 78 divided by 6.
Oh, there it is. Thank you.
Yeah, my bad.
Okay, so it's going to be something gross. So we'll go 44
Simple, yeah.
over 3 equals x. There you go. All right, and that equals x is the radius of C. All right. Thanks for that question, AuthX. Seems like you understood it. We're going to go ahead and wrap up. We're going to talk about what we went over today. Levi, you want to get up here?
I forget what I went over. Oh, vocab and context. I have to go now.
See you here.
So, yeah. So,
Okay.
I will see you people Sunday.
You guys. Quit saying you people. It sounds
Why?
so aggressive.
No, but you guys is exclusionary. You people is maybe disrespectful,
The
but at least
followers?
to everybody.
You
So I don't know.
guys.
Okay. Anyway,
I feel like that's
I'm
just-
going
that's just the
vocab and
language we use
context.
today.
What
It's
you
not-
need to do is not pay attention. You're not
People don't feel singled
finding
out.
the synonyms of the word that you just see in the question. You have to go to the context and you have to see what it defines for you. Okay. I will see you on Sunday. Bye.
Okay. Well, we're doing it that way today. For data interpretation, a couple of things you want to focus on.
Talking, I'll do it.
Hey, thanks, Brady.
You got it.
What you want to focus on for data interpretation, you have to be able to read a graph, table, chart. The best way to get good at that is to practice, right? To get better, you have to practice. That can mean you look a lot at, see everyone, great, see you Sunday, Vinray. You want to make sure that you are being aware of the x values and the y values in terms of the x-axis and y-axis, what they stand for. You want to be very aware of that, and you want to know how they interact. Sometimes they'll ask you about dependent versus independent variables. Usually the x-axis tends to be the dependent, the y-axis tends to be the independent, or
Nope.
no, sorry, independent is the x-axis, dependent is the, thank you, Uncle Bill. That makes, use a guys.
Use
But
guys.
use
guys.
But only if you say it with a Z. So
Use.
use guys
Just,
is pretty neutral.
okay, like
All
they're in
right.
trouble.
Mm.
Use guys.
Use guys.
Uh,
There it is. Okay, you want to be sure that you're remembering that normally or typically the x-axis is independent, the y-axis is dependent. The y depends on the x value more often than not.
correct.
You want to be able to know the relationship between the two. You want to be aware of what the question is asking pertaining to the tables, charts, or graphs. If you have a flat part, like we had on the first question, what does that mean in relation to what the data actually is saying? We talked about scatter plots, line of best fit, what the line of best fit actually is, where it's just an estimation of what those points would be, right? A line that is the closest to hitting all of those. Anything else I'm forgetting for data interpretation?
It was all you, man.
All right. I think that about covers it. We'll see you guys Sunday. And if you have any topics you want us to cover, go ahead and post them down in our Discord.
Be safe.
Yeah, have a
have
good weekend.
fun. And we'll see you soon.
See ya.